As you can see, I am not alone in the office today. I've got a good buddy of mine, John, who flew all the way down from Massachusetts to hang out, and you guys are actually already familiar with some of John's work. He made the side panels for the Mini Centurion, which I showed in a previous episode, and they turned out phenomenally well. Not only that, John took all of the measurements for those side panels at VCF East in the middle of the chaos that is an event like that, and they came out perfectly. It's unbelievable. So the amount of skill it takes to do that is off the charts, but also you've got to have some pretty nice facilities to do that. So you have a shop up in Massachusetts, right?
Yes, sir.
What's your shop called?
CAD Industries.
And what do you do at that shop?
We've got full CNC machining capabilities, sheet metal side and structural steel, and laser cutting.
And yeah, he's not just those side panels, he's actually made a couple other panels for me that haven't made it to video yet, but they will be. One of them is we've got a new cover panel for the Centurion here that's going to fit much better around the floppy than this one, and we're going to color match it as well. But I want to be extra clear here that this is not like a sponsored thing. I mean, I am wearing a CAD Industries shirt. This is awesome, but it's not a sponsored thing. John didn't ask me to do this. I'm just doing it because when my friends are running small businesses or doing something that I think is really, really awesome, I want to support them in any way I can. And this is the best way I know how to support. So I would absolutely love it if you guys would check out his shop. And if you have any metal work, you don't have to be a big business. You can just be an individual. Send John an email and he can help walk you through it. But John, you didn't come down here to talk to me about metalwork today.
No.
John came, I mean, it's pretty obvious. We've got a huge Model 15 teletype sitting on the table here. John has, his basement has been dubbed the Bodo basement because, how many teletypes do you have in your basement right now?
Lost track.
People say that when they want it to sound like a lot, but no, it's like legitimately 10 plus, right?
Yes, it is.
It's a lot. He primarily focuses on 5-bit machines, and this Model 15 is right up his alley. If you were at VCF East in 2023, John had a Model 15 set up on my table that was in loopback mode, and people could come up and type on it. And you went off and enjoyed the show, but I was at the table the whole time, and that teletype had as much, if not more, interest than the full-on Centurion that was sitting next to it.
Sorry about that.
It was awesome. I'm so glad. But this teletype here was a gift from Uncle Stewie. Not my actual uncle, that is his username. So Uncle Stewie, if you're watching, thank you so much for that. He hooked me up with this Model 15, and it's dirty, but I don't think it's in rough shape. You've spent some time looking at this yesterday.
Yes.
After you showed up. So tell me what you think about the condition of this machine and what you think it'll take to get going.
Well, it's definitely dirty, but these things tend to just come right back to life with a little bit of cleaning and lubrication. And I have a pretty strong suspicion that this thing is just going to work.
And everything is kind of moving and free already, right?
Yeah, everything's free. It's a little sticky, but that's generally not a big deal.
All right, so what are we going to do to get this thing going?
Well, we're going to take it apart. We're going to soak it in simple green to get all the old sticky lubricant off of it. And first thing we're going to do is put it back together and lubricate it. And then we'll see where it goes from there and make any adjustments that are required.
Heck yeah. And we also happen to have a very cool looking 1940s telephone and a modem box here. And that means that we can hook the telephone up to it, and this modem box creates a current loop, so we can use this to test the machine ultimately and hopefully get it printing some stuff. But like you said, the first thing to do is to take it all apart and start soaking it in simple green because it's pretty gross. So we're gonna get to work. First things first, let's get this huge roll of paper off. After releasing the pinch rollers, we'll unwind the paper from the typing mechanism, then pull back the 2 tabs that lock the paper roll in place. And finally, just lift the whole thing out. Next, let's work on getting the typing unit off. There are 2 screws on the front, which are normally thumb screws, but have been replaced with flatheads on mine for some reason. But after those 2 are removed, the whole typing unit slides right out the front. My favorite thing about the construction of these old teletypes is that all the components electrically connect with wipers, so there's no plugs or anything at all to disconnect. Next, let's get the printing unit off. It's held in place with 3 thumb screws, 2 on the left side and 1 on the right side. Then it's completely free and you can lift it straight up and out of the way. The last big piece to pull off the base is the motor. It's held in place with 3 screws through the base into the bottom plate. Then we can lift it right off, and that's all the major pieces removed. It only takes about 5 minutes to get to this level of disassembly, making this an absolute cinch to service in the field. Everything is very easily accessible, and I can see why these things are considered to be absolute tanks. There's a little more disassembly to do before we can get to cleaning though. The transmit, receive, and power wires all come in through this guide on the side and are held firmly in place by this clamp. With those out of the way, we just need to loosen the terminal block screws and then the wires can finally be pulled out. And lastly, there's a little line conditioning condenser here that we're going to remove. Line power these days is clean enough that this isn't strictly necessary anymore. All right, check this out. As we're taking this thing apart, we found it. We found the current loop. I don't know what's going on here. We have a little resistor that has been tied into the same point here. So you just got a resistor doing absolutely nothing. If you were the ham that originally had this, what's going on here? This is hilarious. But you know what? I like it, so I'm gonna leave it in place for now. To clean these things up, we're gonna fall back on our dear friend, Simple Green. And we are absolutely not being shy about using the stuff. We'll just spray it on heavy and then pull out a mixture of plastic and brass brushes. The Simple Green breaks down the grime and then the brushes knock it loose. And are you ready for the most satisfying shot of the whole video? Watch how this thing transforms when I hit it with the water hose. Did you see that? It looks like a new piece completely. After a thorough scrubbing and washing, I'll blow dry it with the air hose before setting it in the Texan sun to bake and get completely dry. We want to give the typing unit the exact same treatment, but the keycaps need to come off first. And you're supposed to just squeeze and pull and they should come off, but the Z key was unknowingly glued down and made me think I just didn't know what I was doing. There's one more condenser on the typing unit that we're going to loosen up, but not remove fully. This is so we can get better access to the send unit for cleaning. Then it's right back outside with the Simple Green. Again, we spray it on heavy and let it soak for a little bit, and then check this out. Just a light scrub and you can see the decades of filth lifting right off. The brushes come back out and we get back to work scrubbing, and the Simple Green has lifted up so much filth it's actually hard to tell how clean we're getting it until we spray it with the hose, that is. Then it looks brand new again. While the typing unit is drying off, let's move over to the printing unit. After releasing the carriage lock, we'll remove the carriage belt from the return spring and be careful to slowly release the tension in that spring. Then the carriage slides right off the end, easy peasy. Since the carriage is full of tiny little parts, we're going to drop the whole thing into a small bucket and then fill that bucket to the brim with, you guessed it, Simple Green. Now we'll just let that marinate for a good while. Okay, while the printing unit outside is soaking, we're going to shift back over to this main unit, and we're going to clean it up pretty much how we've cleaned everything else up by spraying it with Simple Green and giving it a big scrub and then washing it off with water. But there is a problem going on with this dash pot right here. So when the printing unit does a carriage return, it slings all the way back and there's a bunch of mass on it. And so you need something to slow that down. So this lever arm goes into this dash pot here to slow it down. And that is gummy and broken and not slowing anything down, and so that's just not good. We need to get the dash pot off of there and take it apart and see if we can figure out why that is all messed up. And then we're going to clean everything else and I don't know, start putting things back together. To remove the dash pot, there are just 3 screws, and wait a minute, that wasn't supposed to happen. It's not supposed to come completely apart like that. All right, that was interesting because when you take this apart and you take the 3 screws that go through the mounting off, it's not supposed to fall apart. There's supposed to be 3 additional screws that hold these 2 pieces together. Those 3 screws are missing, but here's how it actually works. You can see that on the end here we have a kind of rubber cup, and that cup sits on the inside of this cylinder here and it creates a seal. And as the mass of the printing unit comes back, it pushes on a lever which pushes this forward, and pushes that seal deeper into the cylinder. And when it does that, because it's created a seal, it's pushing all of that air out of a little vent on the bottom here. And you can adjust the opening of that vent to adjust how strong or weak the dashpot is. But because that's not happening, that means that this little seal here is not sealing against the cylinder very well. Also, this is like super gummy and gross. So the whole thing's got to come apart so we can clean it up and make sure that this is moving smoothly. And then we got to figure out how to get this cup here to seal on the inside of the cylinder. But it's a pretty simple device, and I think we should be able to bring it back. The dashpot comes apart easy enough. There's just a single nut on the end with the seal. After removing that, the seal and washer can slide right off. Then the shaft can slide out in the opposite direction. After giving it a thorough cleaning, let's reassemble it. The backing plate goes on first, followed by the, I believe, leather seal. Then we cut out a piece of plastic to help push the seal into place. So that goes on next, followed by the top washer and then the nut. And you can just see the plastic piece we cut out here. It's slightly bigger than the top washer, which will help apply a little more outward force onto the seal itself, pressing it against the cylinder. After lubing it up liberally, we just need to slide the whole thing back into the cylinder, which is a little challenging, and actually that's a good problem to have. With the dashpot restored, let's shift focus over to the printing unit. There's nothing on here that can't get wet, so like before, we'll drown the thing in simple green, let it soak, then give it a good solid scrub down before washing it off and then hitting it with the air compressor. While that dries the rest of the way, let's take a look at the carriage that's been soaking for about 4 hours now. As you can see, all the grease and oil is floating on top of the simple green. Gross, but also excellent. So let's pull it out of the dunk tank and give it a good scrub. It is fantastically complex though, and there's a lot of little nooks and crannies we couldn't quite reach. Thankfully, soaking it seems to have really gotten those clean. And after rinsing it off, we'll set it out to dry. In the meantime, we'll get to work cleaning up the keycaps. This is a much more enjoyable process with a buddy helping out. We just got a good production line vibe going on and just had a blast chatting about anything and everything. All right, this is cleaning up phenomenally well. It doesn't even look like the same machine. And we're actually ready to start bolting it back together. There's not even that much to do. There's only like 5 parts and like 6 bolts. The whole thing goes together and comes apart so easily. So we're ready to put it together and start testing. But before we do that, this is a perfect opportunity to take a look at how a teletype works. And actually, you may have made it this far in the video and not even know what a teletype is. And don't feel bad. I mean, this thing is from like the mid-1930s, so it's chasing down 90 years old and not even that far away from 100 years old. That's ridiculously old for a piece of equipment that can do something that is still being done today. Teletypes are very similar to data terminals in that they just are communicating via serial data. So if I push a letter on the keyboard here, like say the letter A, it's going to encode that letter into a specific 5-bit value and then send that 5-bit value out over a wire serially at a specific data rate. In this case, it's going to do it at 45.5 baud, or 45.5 characters per second. Now, if somebody else sends, say, the letter D to me, this machine is going to receive 5 pulses that represent the letter D, and it needs to receive those pulses, decode them, change that into some kind of kinetic motion that swings one of these hammers up and slaps it against the paper like a typewriter to print the letter D on the piece of paper. So the way they do this is pretty insane, and I figured this is what better time than now than to take a look at how each section works. So we've got the keyboard, we've got the send unit here, and everything on this is running off of this electric motor right here. This little synchronous AC motor spins, and the gear ratio between this and the send unit here is spinning this send unit at a very specific speed, and that speed happens to equate to 45.5 characters per second. You can change out the gears on this and get faster or slower baud rates. You know, there's lots of custom gears out there. So what happens when I press a key? Well, the best way to see that is to flip this over to the bottom and take a look at the underside. On the bottom here, we can see where the magic happens for the encoding portion of the send part of the teletype. There's 5 of these bars that run left to right across the entire width, and they push up against every single one of these bars that are running back to forth. And these are the individual key bars. So when I press a key, it's going to push that key bar down. And when that happens, it's pushing against these 5 bars. And these 5 bars have really unique shapes cut into them. So that way, whenever I press a key, it's going to move these 5 bars left or right in a very specific way. And that is encoding our data. Every time those bars on the bottom move left or right, they push on these levers right here. And they are pushing up through the casing, and they push in or out depending on which key I push. So if I push the letter R here, you can see half of them have pushed in and 2 of them have come out. If I push Y, it's the exact opposite. So if I push the letter A, you can see the encoding is essentially out, out, in, whether that's 11000 or 00111, I don't really know. But that's our encoding. Depending on which one we press, you can see as I just go down the keyboard here, we are showing different combinations of these 5 levers in different positions. That is our serial encoding that is happening for all of our keys here. Now this whole time, the electric motor is spinning this shaft back here, but you can see that nothing's happened because there is a clutch that has disengaged it. But the second that you press a key, that clutch lifts away and allows the motor to rotate this camshaft that comes all the way up to here. So let's push the letter R here and see what happens. Now R, we remember, has in, out, in for the encoding. So if we look at these weird kind of question mark shaped pieces here, we should see them move. There we go. That one went out. That one went out. All right. So now let's push Y. This should be the exact opposite. Yep, there you go. You saw that the first one, the middle one, and the last one all moved out. Now, when one of these moves out, it allows these contacts here to actually make contact. And so whether these are making or breaking contact is changing whether we're sending current down the transmit wire that's going off into Never Never Land. So each time we press a key, we are making or breaking the contacts in a specific pattern, and that's our data that's being transmitted out on the line to whatever it is that we're communicating with. So sending data is pretty easy peasy, and we've effectively sent data out into the wherever. If we're sending it to a computer, the computer will receive it, and maybe it needs to send something back to me that it wants to print on the piece of paper so that I can see it, maybe like a login prompt or something. So it's going to send serial data back into the machine, but how does 5 bits beeping intermittently cause this thing to print? And well, the magic is all on this piece here, right here on the side. There's 2 little electromagnets, and this is where really fantastic stuff happens. As the serial data comes in, it either energizes or de-energizes these 2 electromagnets here. And when they're energized, they pull this arm down, and when they're de-energized, they release that arm. And you can see that arm comes all the way over to here, and it just moves a tiny little amount. That's how we're selecting the different bits. Now, how does that work? Well, I'm going to rotate it over, and you can see something interesting happens right up here. See how each one of those arms comes all the way back as I go through a full cycle? There we go. That was one cycle. Here's another full cycle. Those are our 5 selector bits going on right there. And right now, because the electromagnet is essentially de-energized, we're selecting all zeros or all ones. I forget which way it goes. But if I energize this magnet, as it comes through, it pulls that up. The selector bit will start to come backwards, and it'll hit that arm. It can't move all the way back. And now if you look right over here, you can see the sword on the inside. That's what they call these. They look like swords. You can see that sword start to move downwards. See it over there? When it's doing that, it is shifting the position of the selector bars on the front. So now we put them all down, and that's all essentially ones. So I can actually do, like, say 1 0 1 0 1. And you can actually see that the selector arms have stayed as in, out, in, out, in. That's really awesome. So on the front here, you can see that this top selector bar is pointed downwards, and the selector bar underneath it is pointed upwards, and then pointed downwards, then pointed upwards, then pointed downwards. Now let's do one more rotation and just reset everything so it's all facing the same direction. If I just give it a quick spin here, Boom, you can see all selector bars are now pointing upwards. If I hold the electromagnet up, I can go through a full rotation again, and there you go. All selector bars are facing downwards. So depending on which encoded data we have coming in and how those swords are moving, these selector bars are going to be pointed up or down, and that's going to select a different key to slam into the paper. But how's it doing that? Well, that's all happening on this final piece over here. Each one of those selector bars slots into the opening on each one of these kind of 90-degree shaped arms right here. And as that selector bar moves up or down, it moves the arm up or down. And that arm is pushing on this kind of semicircular piece over here, and it's pushing it left or right. And you can see that there are 5 arms and there's 5 of these semicircular pieces. And the semicircular pieces are all very unique. You can see they have fat or skinny squares on them. And what that's doing is it's allowing one of these little bars right here to fall into a gate. And when one bar falls into a gate, that allows the backside of it to catch on the hammer, which then slings a very specific bar up this way to type on the paper. Now, this is madness. Whoever designed this back here was a genius and an absolute mad lad. And we're not going to go into the full detail of that. So all that's left now is to put it together and see that in action. Let's get this thing back together finally. First, we'll get the motor in place. This is actually the best piece to install first, as it makes meshing everything together later easier. Then we'll set the printing unit in place, and man alive, that already looks absolutely epic. I'll cinch it down with some new old stock thumb screws John managed to snag, and then we'll reinstall the freshly rebuilt dashpot. This time we located some extra machine screws and rebuilt it like it was meant to be. Then we'll spin the whole thing around and slide on the carriage, which is finicky at best because a lot of things have to align. But once in place, we'll tension the return spring and hook up the belt. Finally, the typing unit slides right into place in front. Then it's time to absolutely drown this thing in oil. Every account I've heard about the Model 14 and Model 15 says they prefer to be absolutely dripping wet with oil. And since they're running on 120 volt DC, the electrical contacts are actually self-cleaning, as the high voltage will just burn through any oil that gets on them. Pretty much every single piece is going to get a few drops of oil here, and we're primarily using sewing machine oil, but in a few places we're falling back on a slightly heavier 30 weight non-detergent oil. The lighter oil is better for freeing everything up, but really as long as things are smooth and free, either oil type should be no problem. There are of course multiple oil nozzles that need the cap lifted and then filled to the brim with oil. There are also multiple pieces of felt in places. These pieces need to be oiled up too. They act like little long-term oilers, keeping important parts nice and lubricated for a very long period of time. And finally, the electric motor has 2 of these little oil holes on it. You use the tip of your oiler to push the spring-loaded ball down and then squeeze in oil until it wicks in and the motor sounds smooth again. This thing is absolutely drenched in oil, but everything is feeling very smooth and very free. So I think we're about ready to start doing teletype things. So the first thing is flip the power switch and see what happens. It should chatter, but nothing really should be typing or moving or anything like that. So we'll flip the power switch right over here, if I can find it. All right, crazy loud. The next thing we're gonna do is I picked up this absolutely beautiful Asahi Nagashima tachometer. It's a hand tachometer. You push the button on top and it starts a timer on the inside. And then whatever is rotating here on the main spindle will count up. And we can see what the RPM of the electric motor in this thing is. And it should be exactly 1800 RPM. And so we can verify that with this thing, which I think is going to be awesome. I bought this in Japan on my last trip there because it was way cool. And I didn't ever think I would have a use for it. But here we go, a proper legitimate use for this thing. So let's... This is gonna, I'm excited. Let's do this. All right, all I got to do is we got a little rubber nubbin here, and I'm just going to push that against the center point here and let the motor shaft here spin it. And then I'll push this big button on the top and it should go. So John, why don't you flip it on for me? We'll go ahead and get that spinning. We'll hit the button. Oh, it's like 1,795 RPM. That is bang dead on accurate. That is awesome. Did you see that?
Yes. No, I didn't.
Oh man, we'll have to do it again.
Yeah, do it.
All right, I think we're pretty much just gonna go for broke. John has the modem set up here. This is creating a current loop. So we should be able to send an audio signal into the modem. That'll create a current loop that sends that audio signal serially over to here. That'll interpret it and hopefully print it out on the white paper up here. He's got the audio signal coming from the ITTY website that is just a news feed, and it's coming off of his cell phone there, which I find hilarious. So all we gotta do is flip the power switch on here, and he's gotta put the phone on the hook, and we're printing, but we're printing the wrong stuff, but that is awesome. All right, it took us an hour and change, but we figured it out. There was just one tiny little piece all the way in the middle here that was gummy and not moving like it was supposed to, which was preventing a pawl in the back from locking things like it's supposed to. It was just throwing the timing all out of whack. But we've got it going. Check this out. If I flip the switch here, it just immediately starts typing, and it's actually readable. It's just, I mean, it's a news feed, so I don't really have any clue what it's typing, but it's a perpetual news feed coming from the internet through the modem into this. It's typing perfectly. This thing is fully working, and that is epic. But wait, there's more. We got the Model 15 working pretty perfectly last night, and even after I turned all the cameras off, John and I just sat here and like watched it for like an hour as it just churned out perfect copy after perfect copy of news feeds, and it's awesome. It's just this beautiful piece of kinetic art. And so we were talking last night, John. Look, what year do you think this thing is from? Just about.
Yeah, so these things were made from the late 20s, like very late 20s, up until somewhere in the 60s to 70s. It's
like crazy late for these things.
It's crazy. The documentation's a little sketchy in there, but based off of that and based off of some of the parts on this machine, it looks like it's probably dating to the mid to late 30s.
All right, so that would place it about coming up on 90 years old.
Yeah, very close to that.
And back in 2020, when a little thing took the world by storm, I lost my job, and I decided to start a new hobby, and that was working on old computers and old interesting things. And one thing that we got it probably in about 1980, and it had been sitting in our garage for the last 40 years, was this particular teletype over here. And this is a Model 14. We got it from our neighbors in the 1980s, and it would have been 50 years old at that time. At least I think it would have been. So this Model 14 is pretty interesting because it doesn't say teletype on it. It says Morkram Kleinschmidt, which means what? What year would this one be from?
So these were a much more limited production run. The documentation kind of indicates that they were made from 24 to 27, and maybe that's a little broader, but based off of what we're seeing on this machine, it's probably in the 1926.
All right. So That would make it 98 years old
Yeah,
today.
it's probably pretty close to that.
So we have a 90-year-old teletype. We have a 100-year-old teletype. This one works perfectly. And I tore this one completely down, piece by piece, cleaned every single piece up with steel wool, and it all came out looking absolutely beautiful, but I never knew how to build a current loop for it. I never had any way to test it. So I just pushed it off into a corner for the last 4 years. And because of that, it's become all gummed up and gross again. But I've got the expert here, so what better time than now to get this thing going, then plug it into the modem here and see if it can also print out news feeds. Now, it won't be doing it on a big paper like this because this is a ticker tape machine, which I think is even cooler. So we're gonna lube up all of the points on this, pretty much just do exactly what we did with the Model 15, and hopefully we can get this one printing too. I'm excited. This is gonna be cool.
Me too.
This would be very cool.
Just like before, we're going to drench this thing in oil. 4 years ago, when I pulled this thing apart and rebuilt it, I didn't know the first thing about teletypes. And during reassembly, I used a light grease, which is both way too sticky and also now very gross after sitting for 4 years. We're hoping that the light oil that we're using here will break down the grease and get things moving a lot smoother. Every single sliding surface is going to get a generous coat of light oil. And again, the big drive gears on the motor will get some white lithium grease. Once spun up, let's check the RPM on it and make sure it's spinning at the right speed. And yep, that's exactly the same as the Model 15. That's awesome. So let's flip the switch and throw some serial Baudot bits at it. And, okay. So things are still very, very sticky. The machine is so close to working, but as you can see, the hammers just aren't making it to the paper. And to make matters worse, sometimes the hammers get stuck down, which causes other hammers to crash into the back of them, and a hammer pileup occurs. Definitely not ideal. However, the longer we run it, the closer the hammers get to the paper. And after applying even more liberal amounts of oil, the hammers are finally starting to actually strike the tiny platen, even if they're still getting stuck. The two things ultimately solved this: more oil and adjusting the force with which the hammers are thrown. This bar back here was broken when I did the restoration 4 years ago, and after repair I had it backed almost all the way off. With that, we're actually hitting the paper and printing characters now. I mean, they're completely the wrong characters, but hey, that's definitive progress, and the most I've seen this thing do in 40 years. This is absolutely a timing problem. Some mechanical portion is starting too early or too late, which is causing the decoding to go all wonky. Ultimately, it was the alignment of the electromagnet and the selector arm here. Again, when I did this 4 years ago, I never got these aligned right. But after going through and adjusting them to be on point, check it out. That is printing absolutely perfectly. At 100 years old, the old girl is hammering out ticker tape as if though it were brand new. The tape is super legible, and the equal signs that you see on the occasion are actually how it prints carriage returns, since it doesn't have a carriage to return. What an absolute epic piece of machinery.
And fully functional. You guys saw it in the B-roll just there. It's actually printing stuff out. We've had this thing in the family for 40 years and I've never seen it do anything. John's here for less than 5 hours today and we get it fully printing. John, thank you so much for that.
Thanks, man. That was a lot of fun.
So, I love it. The Model 14 is really cool. I always thought the Model 15 was way cooler than the 14 until I saw the 14 print. And they're both equally epic. However, I don't really have a use for having two teletypes in the room. I am, as is very obvious by the stuff in the room, very computer focused. And I do want to get the Model 15 hooked up maybe to the UE1 so we can bit bang it and type out hello world or something like that. But mostly I want the Model 15 here to be the primary data terminal for UE2 when we're going to get into developing that here soon. And so the Model 15 is going to be a mainstay of this room. But I don't particularly have a good use for the Model 14, as beautiful as it is. And this is no surprise to you. We talked about this off camera, obviously. But I can think of nobody more deserving of receiving the Model 14 than John here. John is an absolute legend. Came down here, worked absolute magic. And I think that you can do some pretty wild things with the Model 14, right?
Hell yeah, man.
Pretty excited about it. So you've got a Model 14,
Model 15, Model 28, Model 32,
which means you're missing a
26 and an 11.
A 26 and an 11. So if anybody out there has a line on a Model 26 teletype or a Model 11 teletype, shoot me a line or shoot John a line. I'll put some information in the description below for how to get a hold of him. And we'll get it into the hands of John the Legend in the Bodo basement. And it'll be absolutely epic. Of course, if that happens, there will also be a video of it here on this channel. So, first of all, Uncle Stewie, I want to thank you so much for hooking me up with the Model 15. John, I want to thank you so much for flying all the way down from Massachusetts. And I want to thank all of you so much for watching, and I hope to see you in the next episode.